All right, we have a diverse range of participants. So Afroza is from a pharmacy background. Diksha is a research scholar at Kapar Institute of Engineering and Technology. Afroza and Diksha, can you guys also let me know what are your research interests and with respect to infectious disease? Is there any particular area that you would like to learn more about? And what about the rest of you guys? Julia, Kishore, Mohammed, Samuel. I'm curious to know about you guys as well.
Uh, Thank you.
Yes, of course.
I would like to know more about skin infection. Uh, as you know, skin infection take very lightly in our country, but when I learn about infection and I was make a cross-sectional study in last year where I observed most of the girls, especially women, are infected by skin infection, and they were unaware about that. So I would like to know more about this infection and its uh, ethnobotanical treatment, which is available in our villages and uh, also cheap costing.
Right. Thank you so much, Afroza, for introducing your background and your interests. I'm sure this today's webinar will be helpful for you to learn more about the program. And what about the rest of you guys? All right. Diksha says she's interested in immunoinformatics, and Kishore is Dr. Kishore is PhD in molecular virology and is a passionate academician who work on HIV and antimicrobial resistance and is new in the field of it. Thank you so much, Dr. Kishore. And what about the rest of you? If you're not able to unmute yourself and speak, you can let me know in the chat as well. We'll be starting in just 4 more minutes. We are starting to get some queries. Will you be providing recording of the session? Yes, we will be recording. Thank you for responding, Sparsh. What about the rest of you? I'm monitoring the chat box for your responses. We have a diverse range of backgrounds, participants from diverse range of backgrounds, but So for those participants who are just joined, we'll be starting with the webinar in just a few more minutes. And meanwhile, we are waiting. It would be great if you could introduce yourself in the chat box. Few of the participants have already introduced themselves. I'm curious to know about the rest of you as well. All right. Can the participants confirm if you can see my screen? All right. So let's get started with today's webinar. So hello everyone, a very warm greeting to one and all. My name is Srigauri Krishnakumar and I would like to welcome you all to the webinar on OmicsLogic Bioinformatics Infectious Disease Program. This program is dedicated to the study of viral diversity and its role in epidemic infectious diseases that keep re-emerging, including zoonotic spillover, transmissions between humans, and the process of viral and bacterial disease development. And as a result, you will learn to understand relationships between viral strains and haplotypes, find differences in sequence data, and see the implications for drug and vaccine design. This program will provide opportunities to practice analyzing data to gain hands-on experience with curated datasets from public domain collections guided by experts with bioinformatic experience and knowledge about virology. So before we begin with today's webinar, let me also take a brief moment to introduce you to the team behind the program. We are a US-based bioinformatics company who is working with multiple academic and commercial collaborators to develop easy-to-use analytical tools, and our mission is to make bioinformatics more accessible. And as a part of our mission, our team is working with local and regional coordinators that are helping refine local program logistics and adapting them to the needs of students and researchers around the world. And this training has been completed by over 24,000 participants from 187 countries in over 300 workshops in 6 different specialization tracks that include oncology, infectious diseases, precision medicine, neuroscience, data science for biomedical data. And as a part of the training, you will have access to the OmicsLogic resources, which takes a combination of training modules, data analysis tools, curated project data sets, and interactive sessions with mentors to give the student a clear path of the Bloom's taxonomy pyramid. And this also comes with an access to the OmicsLogic courses, which includes courses on bioinformatics, precision medicine, multi-omics that consist of genomics, transcriptomics, metagenomics, and epigenomics, data science that includes bioinformatics using R and Python, as well as cheminformatics, and example projects of different fields which you could learn from and replicate for your research. The OmicsLogic platform also gives options for analyzing a given dataset. For instance, you can learn bioinformatics without any coding at all. For those interested in opting the non-code pathway, they will be given directions to access the T-Bioinfo platform for bioinformatic processing and analysis of data. The platform includes demo pipelines as well as data management and analysis cloud infrastructure to run the bioinformatic pipeline. And different stages of analysis are performed in different sections on this multi-omics platform. And for those interested in learning to analyze data through coding, we provide the OmicsLogic Code Playground, which will help you develop coding skills while learning popular packages in R programming and Python to visualize, annotate, and analyze complex patterns in biological data. So now to view the various courses and example projects and student projects, you need to first sign up on the OmicsLogic Learn portal. Before that, let me walk you through a brief demo on what a completed profile on the portal looks like. So once you sign up on the portal, these are the features that you need to update on your account. That is, a completed profile will have a profile image, full name with appropriate capitalization, link to your social media handle, a brief bio about yourself that will consist of your education background and research interest. The mentors can view your progress under the Activity tab. The courses you are currently completing will appear under the Courses tab. And finally, after the completion of your coursework, the certificates will appear under the Certificates tab. So with that, let us begin by signing up on the OmicsLogic Learn portal before we move ahead with today's webinar. So I'm pasting the link for signing up in the chat box. So for those participants who have not signed up on the portal, please take a moment to sign up, and I'll show you the various courses and example projects that we'll be making use of as part of the program. So for those participants who are creating an account, I'll show you a brief demo on how you can do that. For that, please click on the Create an Account option that you see here. And when you click on this, you'll have the option to create an account using by one method is by entering your name, email ID, and password. Or you can also sign up using any of your social media handles. This could be your Google, Facebook, Apple account, GitHub account, or even Twitter. So you can simply sign up using any of these social media handles as well. And that will directly take you to the portal courses page. So with that, I'll pause for a couple of seconds for the participants to sign up. And once you have signed up, please put a yes in the chat box so that I know I can proceed further. And I can see that some of the participants are familiar and are joining us for a second or third time. So such participants can put it done as well, that you already have an account on the portal, so that I can know that as well. Have you guys started signing up? Please put a response in the chat so that I can proceed further. All right, Dr. Kumar has logged in. And if you're facing any technical issues, you can let us know in the chat as well. Our team is here to look into the matter. All right, so meanwhile, you guys are signing up. I'm just going to proceed ahead and log into my account so that I can proceed ahead with the webinar. So since I already have an account on the portal, I'm just going to click on the sign in option. So once you sign up, you will be able to see the courses page. So under the courses page, when you scroll down below, you will see a search bar that says looking for a specific course. So here, if you are to enter any of your interested area of research, you can just enter the keyword related to that. So let's say, since most of the participants are interested in infectious diseases, when you type the word infectious disease, you will see the various courses and example projects that makes use of the concept. So for example, we have an example project on tuberculosis infection and treatment. And then we have a host response to malaria infection and COVID-19 project, and so on. So you can take a look at it at your own pace. I'm just going to proceed ahead and show you how you can set up your account on the portal first. So for that, on the blue bar at the top, click on the tab that is Welcome Back with your email ID. When you click on that, you will be able to see your account settings. Here, you will be able to edit your profile. When you click on the tab that on the icon that says Profile, it will show you it will enable you to edit several features. Make sure that once, like I mentioned in my presentation, that your name is in proper capitalization, and you upload a profile image for yourself, add a bio as well that consists of your education background and research interest, and link your social media handles as well. And like I mentioned, under the Activity tab, the community manager and the program mentor, they will be tracking your learning progress. Under the Courses tab, they'll be tracking your you'll be able to track your courses. For example, recently I've been taking up transcriptomic analysis in Python course. And once you complete a project and publish it on our portal, that will be displayed under the project tab. And when you enroll for the program, that will be displayed under the programs tab along with the progress that you're making. And finally, once you complete the courses with the required assignments and quizzes, you'll be able to receive the certificate under the certificates. And another interesting tab that I want to show you is the project tab on the top. So when you click on this, you will be able to see the various student projects that have been completed and published on the portal. So here you'll see a diverse range of top projects ranging from oncology, precision medicine, neuroscience, and amongst it are several projects on infectious disease as well. So similarly, you can just enter the keyword infectious disease and you'll be able to take a look at those as well. So you can navigate through all of this at your own pace. For now, let's start with today's webinar. And for that, I would like to pass on the stage to Mr. Ojasvi Datta, who will be playing a recent recording from Mr. Ilya Brodsky, who will be explaining an introduction to the Infectious Disease Program and an overview about it. So over to you.
Yeah, thank you, Shigori. Do let me know once I share my screen.
Yes, it's not loaded up yet. Can you try sharing now?
Yeah, I'm just trying.
Okay, sure. All right, we have a query from Kishore in the meantime, but the web page is taking time to load. No worries. Once you have signed up, you can put your response in the chat. And if it is taking more time, then you can let us know and we'll be happy to look into the matter. And what about the rest of you? Have you guys signed up as well? All right, thank you so much, Diksha. Yes, Ojasvi, we can see your screen. It's loading up.
Informatics is used in the study for infectious diseases coming from different types of pathogens. And what we'll do is we'll introduce you to curated examples of how you can analyze data, where to find such data, and how to make conclusions. Okay, so what I'll do in my part of the presentation is I will review some of the introductory material about the program. Then I will pass it on to Dr. Raghavendran, who is going to review some of the practical things of how you can get started with some of the types of data that is usually used for these kinds of studies. So Bioinformatics for Infectious Diseases is a program that is designed for biologists, clinicians, students that are interested in virology, microbiology, and immunology that would like to learn how to apply bioinformatics to different types of big data for research and applications about infectious diseases, to design novel diagnostic approaches, to understand how antiviral and antimicrobial drugs are being designed, how vaccines are relying on data and bioinformatics to address new and maybe potentially in the future upcoming disease outbreaks, and also how to understand what are some of the important challenges and questions that remain to be answered and how bioinformatics can help us address those as well. So what I'll do is I'll first explain how some of the questions about infectious diseases are related to bioinformatics. You know, if we can think about this program as just a series of questions that one can ask and use bioinformatics to find potential answers. One question might be, what is a pathogen? What differentiates pathogens from non-pathogens? What differentiates, for example, bacteria that coexist together with humans, plants, and other hosts from those that cause disease? How can that help us understand the evolution or the conditions of competition that cause these microorganisms to evolve, share recipes, kind of record what works and how to adapt the tools that they have to overcome different types of challenges. Another question can be, where do diseases come from? How come is it that some diseases persist and some diseases have these outbreaks that are acute, that have a beginning, that have an end? Where do they come from? How do we understand the origins of diseases like coronavirus or Ebola or other diseases that cause these endemic or pandemic outbreaks? How can we understand this in the context of interaction between different hosts, for example, different species, humans, their pets, the different cattle that we grow? How can that be a source of novel pathogens? What is the actual disease that they cause, right? How can we describe the reaction of the host to the pathogen as a condition that we can diagnose? So what makes that as a disease? And we can think of all of these microorganisms as essentially parasites that leverage some of the resources that the hosts have accumulated, leverage their mechanisms of production of vital proteins to be able to replicate themselves, and how they, as a result of hijacking some of these resources, can also cause toxicity and disruption of the host function. We'll also talk about how diseases spread, because what characterizes an infectious disease or a communicable disease and sets it apart from other types of diseases, which are commonly known as chronic diseases like cancer, for example, or hypertension, is the fact that they're caused by a pathogen, and that pathogen is a transmittable pathogen. You can actually share it between individuals. And so when we think of that transmission and the pattern of transmission, we can also use bioinformatics to understand the population scale. How does the population react to a disease, for example, herd immunity, or how does the population become susceptible, for example, having similar characteristics within a particular group or a population? How can that make them more susceptible to particular types of diseases? And we'll also talk about the balance of replication, how while a pathogen causes acute disease oftentimes, one of its objectives is to continue and replicate and find a balance where it can continue to replicate and spread between many individuals, causing them to potentially have mild condition that does not prevent it from continuing to replicate. Then we'll talk about how to treat or prevent disease, and we'll talk about how novel advances are examples of bioinformatics in part because understanding the particular situations where vaccines can be more adapted to the specifics of the pathogen, and maybe novel antivirals could be designed based on our understanding of the interaction between the host and the pathogen, can lead to novel ways to treat disease. But we'll also talk about how early diagnostics, or understanding specifically what pathogen and what strain of a pathogen, or maybe a variant of a pathogen, is causing a disease, is critical for the future of these kinds of interventions. Because as we will see in the last portion, what remains to be done, we'll see how the same principles of evolution can help us understand how the diseases that are caused by pathogens are only preventable if we can develop systems of early detection and understanding of the evolution that they undergo, because we can identify a precise variant and we can treat that precise variant, but we don't always know how to anticipate novel variants. And to anticipate novel variants and design therapeutics that can potentially co-evolve with these pathogens, there are new strategies and novel understanding about how these types of discoveries can really help us anticipate and prevent future outbreaks. So in the context of this particular online program, what we have prepared on our side are a number of examples, or let's call them case studies. Case studies where we can take curated data sets and start designing bioinformatics projects where we have a question, we have a data set, and then we have a path to answer that question from that data set, or methods of analysis of data that could inform some of our understanding of the answers to these questions. So what are some of these case studies and data sets? One of them is going to be about the Ebola outbreak in 2014 to 2016. Now, what's interesting about this outbreak is that it is one of the first examples where large-scale genomic sequencing was employed almost in real time to track an epidemic, to understand how the epidemic is spreading in a particular region, and then use this understanding to design a vaccine and an antiviral drug. Another example that we're going to look at is going to speak about the spread of COVID-19. And when we think about COVID-19, we obviously hear so much about it in the news, but what is exceptionally, I think, kind of for bioinformaticians is interesting in this pandemic specifically, is that the amount of data and the detail of data is now very rich and very precise, being updated almost in real time from many different regions. So really the scale of the data collection here is unheard of in any other kind of disease. Not only that, this particular pandemic has popularized some of the terms that we rely on as bioinformaticians to understand how genomes of particular pathogens or how molecular biology and kind of the background of how these pathogens cause disease are really becoming understood by even the general public. So today, everyone understands what a variant or a mutation is. Everyone appreciates the ability to study some genomic pattern and try to make inference that has a practical application. We don't have to explain the need to understand and maybe sequence some of these pathogens, because now everyone is in tune with this scientific endeavor to try to really understand how this pathogen is evolving, right? We don't need to explain that it is evolving, right? Everybody knows that. So really, we're going to take a look at some of those data sets in this as well. Another example that we will look at is the development of vaccines to address the kind of chronic or endemic Plasmodium falciparum spread in Africa and in South Asia. We'll take a look at how genomic surveillance and understanding of both resistance to some of the known drugs that are used to treat Plasmodium, as well as the efforts to design an effective vaccine that turns out to be a non-trivial effort that requires a deep understanding of genomic variability across different regions and the understanding of how that genomic variability can be used or leveraged to really find an effective way to interfere. We'll also look at how viruses are not only the result of these kinds of acute outbreaks of infectious diseases, but we'll also see how there's a greater appreciation of the role that viruses play in other types of diseases. For example, in neurodegenerative diseases like multiple sclerosis, where maybe an exciting idea resulting from this observation is that if we treat the virus, if we find a way to treat the virus, the viral infection, we don't have to deal with the symptoms, with the consequences that are the outcome of this persistent infection leading to these long-term deterioration of the cognitive function. We'll also take a look at how these types of observations are relevant in diseases like cancer, where Epstein-Barr virus and others have been found to play a major role in the onset and maybe development of these cancers. So I think really infectious diseases now is going from some of these prominent case studies that we're going to take a look at, like Ebola, malaria, and COVID, and even extend to some of the typically considered as infectious diseases, but chronic diseases that potentially have a connection to viral pathogens and others. We'll also look at some of the challenges that still remain to be addressed, even though we think of treatments like antibiotics, for example, as an established way to treat disease that have been very successful over the past several decades. These kinds of interventions are new. Our ability to design vaccines and adapt them to particular pathogens is something that happened in the past maybe decade. Our ability to leverage the antibiotics to treat these bacterial diseases is also just a few decades old. And as a result of widespread use of these types of interventions, we're also seeing the reverse reaction, right? Where we are seeing how these types of interventions can become weaker over time as a result of evolution and adaptation. We see emergence of resistance, and drug-resistant tuberculosis, for example, is a major risk. We can see novel pathogens, bacterial pathogens that are emerging in hospitals that are not possible to treat with antibiotics. We're also seeing novel variants of these viral diseases that also do not respond well to vaccines that were designed. So really, these are some of the challenges that continue to emerge in these kinds of effective ways to leverage bioinformatics. And we'll talk about where we can find some data sets and what are some of the methods of analysis that we can leverage to try and answer some of these questions and challenges. Now, where can you find some of these? We have designed a portal where our team has curated project examples and tutorials that you can leverage as an independent learner, as someone who just wants to obtain some bioinformatics skills, or as someone that would like to apply some of the bioinformatics skills to a particular research question. And so those are some of the things that you will find on the portal, and I will explain today how you can leverage this portal more effectively in the context of this online training portal that is going to provide you with live sessions, as well as some of these online resources that you can leverage to really master some of these skills and practice them on particular examples. So to talk about this, I'll speak about where you can find a particular resource that you might be interested in, how you can find different categories or even collections of different courses, and we'll see how to get started. Now, beyond this, I want to mention that what you will hear in this program is going to be based on tutorials that were prepared in collaboration with a number of experts in this domain. So really what we did is we worked with a number of researchers that are actively investigating all of these topics from the perspective of pure bioinformatics or an algorithmic perspective, how to design methods to analyze such data effectively. We've worked with researchers that specialize in some of these pathogens and have been performing research in the area of malaria or coronaviruses for a long time, and also people that apply the bioinformatics to connect the biological questions with the specific data sets that are available and are being extended and populated with these new viral and bacterial genomes, or even parasite genomes in the case of malaria, to try and answer these questions comprehensively. So we'll leverage their expertise and we'll present to you some of the findings and questions and solutions that they have identified. So what is this program all about? This program, Bioinformatics for Infectious Diseases, is going to help you understand pathogens and the diseases that they cause, where they come from, what are the processes that cause the different types of changes in their genomes that we can observe, how can they cause infection, and how can that infection cause disease. We'll also talk about the specific ways to analyze such data. A lot of this data is going to be focused on the understanding of genomic variability and how to identify specific genomic variants and characterize them in terms of their impact on the pathogen itself, on the interaction between the pathogen and the host, and potentially on the intervention in that interaction. We'll also talk about how you can apply some of these principles to study a variety of different curated data sets, identify the questions that are important for these data sets, and then use the data sets and the methods that we describe to find answers to these important questions. And again, you will have access to some resources that will make your life easier if you're just getting started, but also for those of you that are already more advanced, we will help you connect the dots and really apply these methods in an effective way. Now, the program is going to help you by leveraging two primary resources that I want to introduce briefly before we begin. The first of them is going to be our big data analysis platform. Some of these data sets are going to be exceptionally large. We're going to leverage hundreds, if not thousands, of genomes at a specific time. We're going to look at complex data like RNA sequencing, even single-cell RNA sequencing. And so to facilitate some of the educational aspects of our interaction, we're going to rely on this platform that I'm going to demonstrate in just a few moments. The other part is, of course, our OmicsLogic portal that I already briefly mentioned, but I want to highlight the significance of this online resource because it provides a collection of elements that are going to be useful as you start in this particular program and continue after that so that you can understand the high-level overview in a short program like we have today, but then continue by leveraging some of the specific technical tutorials to really expand and practice and master these skills so that you are independent and confident in the way that you apply them.
Thank you so much, Rajashree, for playing that recording. So now, for more details about how you can enroll for the program and the session details and fee structure, I would like to pass on the stage to Mr. Shubham Kumar. Over to you, Shubham.
Thank you, Shigori. Hello, everyone. I'm Shubham, the Business Development and Marketing Associate at Pine Biotech. I'll be briefly explaining about the registration process for the infectious disease program. So just a second, I'm sharing my screen.
Yes, we can see your screen, Shubham.
All right. So as you can see on the screen that this is the program page of like upcoming program, Infectious Disease Bioinformatics Research and Applied Genomics. And here you can see the date that it will commence from 17th Feb, and only few days are left for the enrollment part. When you will scroll down, you will see a program overview section. Here you will be getting to know about what all the topics and concepts you will be learning by going through this program, like the transmission between humans and the process of viral disease development. You will also get to learn about the relationship between the viral strains, and apart from that you will be working on some of the project examples so that you will get a hands-on experience of how to work with the data sets available on the public domain. When you will scroll, when you will come down, you will see an interactive, you will see a calendar with some of the dates highlighted like 17, 21, and 24. And on the right hand side of that, you will see what all topics we will be covering on that particular date. Like on Feb 17, which is the first session, we will be taking the topic like the next generation sequencing viral genome in host transcriptome, and these are the topics you can see we will be covering. And on similarly on the next session we will be going through multiple sequence alignment and phylogeny, and you will see get to see here. When you will scroll down a bit more, you will find that we have three different tenures for this program. One is for 45 days, 60 days, and 90 days. So the common resources for all these three tenures are like online tutorials, project examples. You will be getting hands-on coding sessions also. And by chance, if you miss some of your session, then we will provide you with the recordings. Apart from that, you will get the complete mentor support and technical support. And after the completion of this program or your tenure, we will provide you with this certificate. And also you will get access for the T-Bioinfo server, from where you can go, you can like run your data and analyze your data. And the extra feature for the 60 days is you will get a one-on-one mentorship mentor session to interact, to clear up your doubts, or to work on your research project. Even though you can discuss with a mentor for your research proposal, and after that you can showcase your proposal as in form of a poster presentation. And for the 90 days, apart from these benefits, you will be getting an extra time to work on your research project and get it published in the peer-reviewed journal also. Now coming to the pricing part, as you can see here, for the 45 days in INR, it is 7,500. For 60 days, it is 9,999, and for 90 days, it is 14,999. Let's say if someone who is residing in US, so you will find a drop down here where you can simply click and select your currency, like in USD. You will see the pricing like 45 for 150, and for 60s it is 300, and for 90 it is 450. Now to know more about the benefits of 90 days and the project examples, I would like to pass on the stage to Sonalika. She will be telling you about the projects and hands-on experiences. Over to you, Sonalika.
Thank you so much, Shubham. Let me share my screen. Grigori, can you confirm if my screen is visible?
You can see your screen.
Thank you. A very warm good morning, good evening, or good afternoon, in whichever part of the world you are. I am Sonalika Ray, Bioinformatics Project Manager at Pine Biotech, and I would like to discuss about the applications and areas of research in the field of infectious diseases, examples of infectious diseases research, data repositories for infectious diseases, and we'll also discuss about some case studies on the portal and some outcomes of the research fellows projects on infectious diseases. Infectious diseases, or the research, plays a very crucial role in understanding the prevention and control of these diseases. I would like to discuss some examples of the application and areas of research in the field to begin with. The first field is vaccine development. Research into infectious diseases is critical for the development of vaccines to prevent their spread. For example, researchers are currently working on developing vaccines for diseases such as COVID-19, Ebola, and Zika virus. Then comes antimicrobial resistance. AMR is a growing problem, and research into infectious diseases is essential for understanding the mechanisms of resistance and developing strategies to prevent it. One of the applications is also to design or develop diagnostic tools. Research into infectious diseases is crucial for this development of rapid and accurate diagnostic tools or tests for disease detection. For example, researchers are currently working on developing point-of-care diagnostic tests for diseases such as tuberculosis and HIV. For epidemiology and surveillance as well, infectious diseases research plays a very crucial role, as the spread of infectious diseases is essential for their control and prevention. The research helps to do the same. For example, researchers are currently studying the spread of COVID-19 to understand its transmission dynamics and develop effective control measures. For host and pathogen interactions, Research into these interactions between pathogens and their host organisms is essential for understanding the mechanisms of disease and developing effective treatments. Research into the immune responses to infectious diseases is essential for understanding how the body defends itself against these diseases and developing immunotherapies to treat the same. Also, research into the prevention and control of infectious diseases is essential for developing effective strategies to reduce their impact on public health. For example, researchers are currently studying the effectiveness of measures such as social distancing, contact tracing, and mask wearing to control the spread of COVID-19. And last but not the least, One Health approach that recognizes the interconnection between human health, animal health, and the environment, and research into infectious diseases often takes a One Health approach to understanding the transmission of these diseases between different species. Infectious disease research often focuses on specific pathogens or organisms that cause the disease. I would like to discuss a few examples of infectious disease studies with these organisms. The first one is malaria. Research on malaria focuses on the parasite Plasmodium, which is transmitted to humans by the bite of infected mosquitoes. Studies aim to understand the biology of the parasite and develop strategies for prevention and control. Another one, tuberculosis. Tuberculosis is caused by the bacterium Mycobacterium tuberculosis, and research focuses on understanding the biology of the bacterium and developing new treatments and diagnostic tools. Or influenza, that is caused by the influenza virus, and research focuses on understanding the biology of the virus, developing vaccines, and monitoring its evolution to predict future outbreaks. HIV/AIDS, that is caused by the human immunodeficiency virus, and research focuses on understanding the virus, developing treatments, and developing a vaccine. Ebola is another type of a research domain or a track that one could work on. Ebola, that is caused by the Ebola virus, and the research focuses on understanding the biology of the virus, developing treatments and vaccines, and studying the disease's impacts on the community. The Ebola virus is a zoonotic disease, meaning it spreads between animals and humans, in this case from fruit bats to humans. Once in humans, it easily spreads from person to person through contact with blood and other body fluids. The genomic analysis revealed that current version of the virus in West Africa most likely spread from Middle Africa within the past 10 years. They also found that the viruses causing this outbreak and the two previous ones diverged from a common ancestor around 2004. This means that these outbreaks arose from different jumps from animal reservoir to the human population. The initial case or index patient was reported in December 2013. An 18-month-old boy from a small village in Guinea is believed to have been infected by bats after 5 additional cases of fatal diarrhea occurred in that area. An official medical alert was issued on January 2014 to the district health officials. And another interesting infectious disease that is most researched on is SARS-CoV-2. COVID-19 is caused by the SARS-CoV-2 virus, and research focuses on understanding the biology of the virus and also developing treatments and vaccines and studying the disease impact on populations and healthcare system. These are just a few examples of infectious disease studies with organisms. The study of infectious diseases is a rapidly evolving field, and new research is constantly uncovering new information about the pathogens and organisms that cause the disease. Viruses are constantly evolving and changing. Every time a virus replicates or makes a copy of itself, there is a potential for there to be changes in its structure. Each of these changes is a mutation. A virus with one or more mutations is called a variant of the original virus. Some mutations can lead to changes in important characteristics of the virus, including the characteristics that affect its ability to spread and or its ability to cause more severe illness and death. It is normal for viruses to change and evolve as they spread between people over time. When these changes become significantly different from the original virus, they are known as variants. And to identify these variants, one can imply NG sequencing to compare the whole genome sequences and compare it with the reference genome to see if they have changed. A detailed comparative analysis of the whole genome sequence, like multiple sequence analysis and phylogenetic analysis or reconstruction, can help us understand the viral adaptations that lead to increased virulence, the geographic spread of the epidemic, and various other characteristics of the pathogen in general. For example, this analysis will also place any new strain in their respective clades that characterizes several viral strains. This identifies the closest relative and hence the strain from which the novel isolate could have been evolved. This can give us major clues to treating the infection, stop its spread as it did during the Ebola outbreak in African countries. So this was about some of the infectious diseases. We would be covering few case studies based on these different organisms in the program, and I'll just give you a gist of what all specific case studies they would be. Before we do that, let's now discuss about some data repositories that could be leveraged to retrieve data for research on infectious diseases. There are many sources of data and information on infectious diseases, both at the national and the international level. Here are some most commonly used data resources. The first one is WHO, which is the leading international agency for public health and provides data and information on a wide range of infectious diseases, including reports on outbreaks and epidemics, surveillance data, and guidelines for disease control and prevention. The next one is CDC, or the Centers for Disease Control and Prevention. The CDC is the US federal agency responsible for public health, and it provides data and information on infectious diseases affecting the US population, including surveillance data, guidelines for disease control and prevention, and resources for healthcare providers. The third data repository, European Center for Disease Prevention and Control, ECDC. The ECDC is a European Union agency responsible for disease control and prevention in the EU, and it provides data and information on infectious diseases affecting Europe, including surveillance data, risk assessment, and guidance for disease control and prevention. The fourth database or the repository that I would like to discuss is the ProMedMail. ProMedMail is an electronic reporting system for outbreaks of infectious diseases and other public health events, and it provides real-time updates on outbreaks and epidemics from around the world. Few more repositories to discuss about: Gideon, which includes Global Infectious Diseases and Epidemiology Online Network. Gideon is an online database of infectious diseases, and it provides data and information on the epidemiology, diagnosis, treatment, and control of infectious diseases. Then we have EIS, that is Epidemic Intelligence Service of the CDC. The EIS is a training program for public health professionals, and it provides information on emerging infectious diseases and outbreaks, as well as training and resources for disease surveillance and outbreak investigation. The next database that we would explore is NNDSS, National Notifiable Diseases Surveillance System, for collecting and reporting data on notifiable infectious diseases in the US, and it provides a comprehensive picture of the incidence and distribution of infectious diseases in the US. And finally, we will also explore NCBI virus, that provides access to a vast collection of biological data, including information on viruses. During the program, we will discuss about various case studies on tuberculosis infection and treatment, viral mutation landscape study using ultra-deep circulatory sequencing of polio, enterovirus T68 and acute flaccid myelitis in kids, and Ebola. Those who enroll for 90 days would get an opportunity to work on research projects with the mentors once their training is complete. I would like to take you through some of the project outcomes from our previous programs. The research fellows and also the program participants worked on organisms like monkeypox and SARS-CoV-2 as well. And these research projects could be found on the OmicsLogic Learn portal. When you click on the projects tab, we have various research projects under the field of infectious diseases, where these researchers, the research fellows, and also the program participants try to work on and establish research on different infectious diseases. And most of them also got some publications, and I would like to share some publications with all of you. These publications were around immunity against respiratory viruses, viral genomes, Zika virus, SARS-CoV-2 pathogenesis, poliovirus, virus spread and virulence, and RNA virus mutational fitness landscapes. These were some of the publications that the researchers successfully got out after the infectious diseases training program. That's all that I wanted to discuss, and we will now meet you all in the sessions and work on exciting, great projects together while making this program a useful resource for you all. Thank you, everyone. If there are any questions, you can please put in the chat box. Our team is still here. We can help you access and also get your questions clarified.
Thank you so much, Nalika. There is a question from Sakshan Bhatia. Will they teach from scratch on how to make the research part?
Yes. So when you say how to work on the research part, yes, we will take you from the very basics. In the training program, we'll talk about these different types of data that could be explored to work with different types of infectious diseases. And when it comes to data exploration or retrieval from these repositories, how do you extract the data sets? How do you prepare the data sets? And then how do you carry out the analysis? And finally, how do you interpret your results to get some meaningful insights out of your analysis? So from the basics till the very end, you will have the mentor support, and we'll take you through the research project in this direction. Yes, definitely. You can also work on a parasitic organism. Because this program is very specific to infectious diseases, so yes, any of the infectious diseases that you would like to work on, you can, be it any virus or be it any pathogenic organism.
Thank you so much, Nalika. Does any other participants have any other queries? If you'd like to, you can unmute yourself and let us know as well about your queries. Dr. Sudhir Kumar is asking, since I don't know any coding, will it be a problem?
No, it won't be a problem at all. So there are two things here. If you want to explore the T-Bioinfo server, you can definitely do that. We have automated pipelines. We have AI-built algorithms and tools in the pipelines that you can use for your analysis. I would like to share my screen here and quickly show you what the platform has to offer. And if you really want to use or explore the scripts only for your analysis, on the specific type of disease that you want to work with. In that case, we also have R and Python programming courses for biomedical data or for infectious diseases research. And those courseworks will teach you the scripts from the very basic or the beginner level. So that won't be a problem. And if you're not a coding person who does not want to into the coding direction or use a script for your analysis, then definitely you have the T-Bioinfo platform where you have these pipelines which include various tools and algorithms that could be used very easily. Otherwise, you would need to have a high computing system with good storage to have these tools downloaded or installed in your system and then use them for your analysis. So in that regards, using the pipelines on the T-Bioinfo server is a benefit for you, where you can process the data very easily from the FASTA or the FASTQ files that you get from different sequencing techniques, and you then explore it. I won't get into much depth right now, but yes, you have the option to use this AI-built pipelines which use different algorithms to process your data. Yes, Noorani, once you complete the training program and start working on your research project, you can successfully publish your research in a journal. We would be assisting you with your research, and if you are highly motivated to work on a research project and get a publication out of it, then nothing can stop you. Our assistance would be there. Yes, Mohammed Cameron needs the contact details. Sparsh, can you please share your contact details? Thank you. You can contact Ms. Sparsh Thar. She is the marketing manager. She has shared her contact number, which is also active on WhatsApp. And you also have an email address in the chat box. You can email her for any queries, and Sparsh will help you get enrolled in the program successfully.
Thank you so much, Sparsh and Sonalika. Does participants have any further queries? If so, please let us know. Otherwise, we'll be ending today's webinar. All right. Thank you so much, Nuran. What about the rest of you? If along the way, if you're having any queries, please feel free to reach out to Sparsh through the email ID or the contact number that I've provided. So please take a note and keep it saved. All right, then. Thank you so much. And we look forward to seeing you for the infectious disease program. Thank you, everyone. Have a great day.